All right, so we want to determine the rate law for this expression. And so which trials would you like to start with?
1 and 2
Okay, so we're going to determine what the rate or what the order is for hydrogen by comparing these. When the exponent there is a 1, so that means it's first order with respect to the hydrogen. So which trials would you like to do now?
4 and 5.
4 and 5. So in 4 and 5, we've got a 0 change for the hydrogen. We've got a doubling for the iodide. And what happens here?
8.
Goes up by a factor of 8. So 2 equals 8 when the exponent is a 3. So it's third order with respect to the iodide. So it's asking you for the entire rate law expression. So we're going to need to actually calculate out the K. So we need rate is equal to K hydrogen to the first, iodide to the second. So we'll rearrange that for K. So K is equal to rate divided by hydrogen to the first and iodide to the third. So then we can pick any trial we want. So I'll just put in, I'll put the first one in. So 0.04 divided by 0.01 times 0.05 cubed. And let's see, we get 0.04 divided by 0.01 divided by 0.05 cubed. So 3.2 times 10 to the fourth. So then the overall rate law for this is going to be rate is equal to 3.2 times 10 to the fourth hydrogen to the first, iodide to the third. The overall order for this is 4. You just add the exponents up. It's an easy way to determine what's going to happen if I double everything or triple everything. So the next question is what happens if I double both? So then I just go 2 to the fourth. And so this will end up going 16 times faster. Does that make sense? What happened when we doubled hydrogen? The reaction doubled. And what happened when we doubled the iodine? It went up by 8. So if I doubled them both, I'd get 2 times 8. So it'd go 16 times faster. All right. What do we want to pick here? Say 1 and 2. No change here, a double here, I get a double here. So first order with respect to the nitrite. And then, what's a good one? Looks like 0 there, a double there, a double there. All right, so first order with respect to the ammonium. All right, so that one's super easy. So then we can go rate, all right, K is equal to rate divided by divided by 0.01 and 0.2. So rate is equal to 2700 NO2 negative, the first, and ammonium to the first. Do you guys feel okay with those?
So when it says rate law expression, that's when you just have the K in there. It's just like you haven't found K. When you want the overall rate reaction, you need the value for K plus your value, plus your exponents on the brackets.
Yes. Oh, actually, I guess I didn't need to answer this. This question right here was only asking me about those two things. It didn't actually ask me about the 2700 and the overall rate law. So what do you want to do with this last one?
Here's the active site of the enzyme.
So the substance, the inhibitor, it's fighting with the substrate to get access to the active site on the enzyme. So whenever the substance, the inhibitor, is engaged with the enzyme, then the enzyme can't do its job, and so the whole reaction slows down. And then how do you overcome it?
Let the system substrate the enzyme can work on.
Okay. Do you remember the example I gave? Antifreeze is the substrate, not a substrate that you want inside of you, the ethylene glycol, but if you flood it with ethanol, just drinking alcohol, then you'll never produce the toxic ketone that will be produced if the liver gets access, if the liver enzyme gets access. So kids who drink and dogs that drink antifreeze, you do what with them?
Get them drunk.
Get them drunk. Very, very drunk.